All right, in example 2, we have a rectangle, and we're going to fence that rectangle, but there's a wall on one side, and so we just need fencing along the other 3 sides that aren't part of the wall. So if I call this length x, obviously, this will also be x. Well, there was 150 meters of fencing to begin with, and so I've taken this x out and this x out of the fencing. That's 2x. So what's left for this side of the fence is the 150 that I started with minus the 2x's I took out for the width. So area is length times width, and the area is a function of x. So I'm going to write that as a of x, not just a. And if you think about a reasonable domain, if I put the fence right against the wall, I'll have an area of 0. But if I put it right against the wall, then these x's will be 0. If I have the fence come out and then back again, I can split that 150 into 75 and 75, and again that would be the other possibility. But for this to be reasonable, we want some sort of positive area, so I'm not going to have it be equal to 0 or include 75. To find the values of x, the width of the rectangle, that will make the schoolyard 2,000, I'll type in the area function. That'll give us this parabola. And I'll type in 2,000. This will give us this vertical line where there'll be 2 answers, where x will give me the area of 2,000. So like before, we chose that menu. Just as a quick reminder, we have to set our window, and that's where the idea of the domain comes from. And we said that the window should start at 0 and go as far as 75. And let's have the x scale mark the x-axis at every 5. If I graph it now, looks like I see the 2 ends of the parabola, but it doesn't go high enough. So if I do whatever, let's say 100 times 100 give us plenty of room. That'll be 10,000. Oops, wrong place. So the y minimum would be 0, and the y max will be 10,000. Let's see how crazy I was there. Let's have the x scale, the y scale, mark the y-axis at every 100. Graph it now, and I overshot it by double. So let's go back to window, and let's have the y max not be 10,000, but how about 5,000? That seems more reasonable. If I graph it, and there we go. To find the first intersection of the blue and the red graph, I'll do second and calc. Choice 5 is intersect. The first curve is the parabola, just press enter. The second curve is the horizontal line, just press enter. And I want the one to the left, so go to the left, 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 left. That's close enough, that should get it there. Press enter a third time, and 17.34 or so gives us a y value of about 2,000. And the directions say round to 3 decimal places. So let's go back and take a look at what it said again. And it's 17.344. 17.344. And for you A students out there, you're right. This should not be equals, this should be approximate because we're rounding. You should go ahead and practice finding this other point using the intersection choice. To find the largest area, which will give us the maximum area, we first of all want to do it without a graphing device. So we multiply this out. Here's our A, here's our B. Negative B over 2A gives us 37.5 feet. To find out the y value when x is 37.5, I can go to Second, Calc, choose 1 for value, asks us what x is. We type in 37.5 and enter, and we get about 2,812.5 square feet. This question is in, ooh, wait a second. I think this question's in meters. I think I made a mistake. It's a good thing we caught that together. So let's change this to meters. And I think we'll be good to go. This actually did the maximum. You can practice that now if you want to, but you'll see in both cases we'll get the same area.